Okay, so welcome to section 8.4, which is polar coordinates. Polar coordinates. Equations. And graphs. Okay, so let's recall. So for all points, x comma y, in the plane, R2, this implies that the radius, or the distance to the center, or origin, is the Pythagorean theorem, square root of x squared plus y squared. And the angle made with the positive x-axis is inverse tangent of the quotient y over x, pardon me, with respect to the quadrant in which x comma y lies. So we have to consider that when we're finding the angle. So definition. Okay, so let's let x comma y be a point in the plane. So be a point in the plane. Then the corresponding polar coordinates. So the corresponding polar coordinate. That's what we're defining, the polar coordinate. Meaning the point that's at the same point, but is given in polar form, is given by r comma theta, so radius comma angle, where, of course, the radius is the square root of the sum of the components, sum of the squares of the components, x and y, and theta is inverse tangent of the quotient y over x with respect to quadrant. So with respect to quadrant. Okay, so I think this might be easier via example, so let's go ahead and do an example. So for example, let's express the following rectangular coordinates in polar form. So express the following. Rectangular coordinates, meaning normal x comma y coordinates in polar form. Okay, so number one, let's say we have negative 3 comma 3 times the square root of 3. So in this case, we have that x is equal to negative 3, and we have that y is equals to 3 root 3. So together, these mean that the radius r, actually let me put it up here, will be the square root of quantity negative 3 squared, plus quantity 3 root 3 squared. I think that, yeah, squared. Okay, so do you agree if I square, a negative 3, I get a positive 9? And if I square 3 times 3, I'll have 9 times 3. So what I have underneath here is 4 times 9. I have 4 times 9 underneath this radical, which comes out as 2 times 3, or 6. So my radius is 6. The angle theta, on the other hand, is inverse tangent of the quotient y over x. So in this case, 3 times the square root of 3 divided by -3. Okay, so we get that theta is inverse tangent. So the 3's reduce, and I'm left with a negative root 3. Okay, so usually negative tangent would mean I'm in quadrant 4. However, the point -3, 3 root 3 is in quadrant 2. So I'm looking for the equivalent angle in quadrant 2 that has tangent being equal to root 3, or negative root 3 as the case may be. So that means that the sine coordinate, the y, is larger. Usually that would be at a 60-degree reference angle. So in quadrant 2, that's going to be twice 60 degrees, or 2 pi over 3. And this is because the point -3, 3 root 3 is in quadrant 2. So we go to quadrant 2 for that. Okay, let's do another one. Number 2. Let's say I give you in rectangular form -7, -7, which we know is in quadrant 3. Let me make that negative a bit better. So I'm just going to go ahead and state it right now in quadrant 3. So when we look for the angle, we're going to have to push the reference angle into quadrant 3. So we are given that x is, let me keep this, -7. And we're given that y is -7. So it looks like this is a 45-degree reference angle. So the radius will be the square root of quantity -7 squared plus quantity -7 squared, or 2 times 7 squared. So therefore the radius will be 7 times the square root of 2. Okay, now the angle theta, I know is inverse tangent of -7 over -7, y over x. So I have inverse tangent of 1. So normally that would be in quadrant 1 at the 45-degree angle. But I'm in quadrant 3. So the 45-degree angle in quadrant 3 is 5 pi over 4. And this is because, once again, our point -7, -7 is in quadrant 3. So I pushed the reference angle into quadrant 3. Okay, so number 3. Let's say we have the point 2 times the square root of 3. 3, square root of 3, not root 2, -2. So this is in quadrant 4, right? So now tangent will be normal for our normal inverse. So x is 2 root 3, and y is -2. So my radius will be the square root of quantity 2 root 3 squared plus quantity -2 squared Oops, no, that's not going to work. Okay. No. Okay, why does this hate me? Nope, okay. Really doesn't want me to just draw this thing. Okay. Momentito. Okay, so I have 4 plus 4 times 3 is 4 times 4. So the square root of that is just 4. So with the angle theta, which I know to be inverse tangent of the quotient y over x, in this case will be negative 2 divided by 2 root 3. So I have that theta is inverse tangent. Oh, do you know what I forgot to do? I need to go back. And this is going to be negative 1 over root 3, which is in quadrant 4. So that corresponds to an angle of cosine being the longer guy and sine being the shorter guy. So that's a 30-degree reference angle, which is 11 pi over 6 in quadrant 4. Let me put because in quadrant 4, but now I need to finish all of these. So 2 root 3, comma negative 2 is in quadrant 4. I forgot to answer the question, which is, what is r comma theta? So formally, how shall I draw this? Maybe. So we have r comma theta is equal to our solution. Okay, let me copy and paste this. Copy. Okay, so we have that the radius here is 6, and the angle theta is 2 pi over 3. So that's the polar form of the coordinate in that second case. Sorry, in the first case. So in the second case, pardon me, our r comma theta will be 7 root 2, and our theta will be 5 pi over 4. And last but not least, over here, we will have that our r comma theta is 4, comma 11 pi over 6. So that's how we write the coordinate in polar form. Okay, so hopefully that makes sense. Let's go backwards now. So for example, let's express the following polar coordinates in rectangular form. So express the following, polar coordinates in rectangular form. Okay, so number 1, what do I give you? I give you 4, comma 5 pi over 6. So we know that our radius r is 4, and our angle theta is 5 pi over 6. Okay, so in order to find x and y, I know that x is going to be r times cosine of the angle, and y is going to be r times sine of the angle. So this will be r cosine theta times r sine theta. Okay, so x is going to be 4 times cosine of 5 pi over 6, and y is going to be 4 times sine of 5 pi over 6. Okay, so what do we have? 5 pi over 6 is in quadrant 2, and it's a 30-degree reference angle. So for cosine, that's a negative root 3 over 2. And for sine, that's going to be a positive 1/2. So what we get in the end, let me move these to the left a bit. I have a little more room. I get that x is negative 2 root 3. Yeah, boy, I do need to move this over a little bit more left. Oops. Oops, oops, oops. Where'd it go? Gotta love technology, by which I mean I hate technology. Okay, so minus 2 root 3, and y will be positive 2. So the coordinate x comma y. So x comma y is equal to x comma y is negative 2 root 3, comma 2. Okay, so let's do another one. Number 2. So let's say we have the coordinate 2 comma 4 pi over 3. So once again, we have a radius of 2, and we have an angle theta of 4 pi over 3. Sorry, I changed the number, the color scheme. Sorry about that. Okay, so together we get that x is equal to, and y is equal to r cosine and sine of 4 pi over 3 respectively, or the angle theta. So for us, this is going to be 2 times cosine of 4 pi over 3 for x, and it's going to be 2 times sine of 4 pi over 3 for y. Okay, so we are in quadrant, let's see, 4 pi over 3 is in quadrant 3. So both sine and cosine are negative. So this becomes 2. Cosine will be negative 1/2 in quadrant 3 at the 60 degree reference angle. And sine is going to be negative root 3 over 2. So when all is said and done, we get that x is going to be negative 1, and y is going to be negative root 3. So our coordinate x comma y is equal to x is negative 1, pardon me, and y is negative root 3. So that is the corresponding rectangular coordinate for that one. Okay, so I think I'll just do one more example for this video, then I'll do another video. So number 3, move this down a bit. Okay, so let's do 10 comma negative, no, let's just do positive 7 pi over 4. Okay, so my radius is 10, and my angle theta is 7 pi over 4. So 7 pi over 4 is in quadrant 4. So what do we get? We get that x will be r times cosine of the angle theta, whereas y will be r times sine of the angle theta. Okay, so what do we get? We get the radius is 10 times cosine of the angle is 7 pi over 4. So that reference angle is 45 degrees, but I'm in quadrant 4, so I know cosine will be positive and sine will be negative. And they're both root 2 over 2 because it's a 45 degree reference angle. So what I get then for x is going to be positive 10 times positive root 2 over 2. Whereas for y, I'll have a positive 10 times a negative root 2 over 2. So in the end, what we get for x is 5 root 2 And what we get for y is a negative 5 root 2. So our coordinate in rectangular form, x comma y, is equal to, the x coordinate is 5 root 2, whereas the y coordinate is negative 5 root 2. And there we are. So I think I'll stop here for this first video.